Hi guys, welcome to Pencil College. In today's video, we'll be discussing about perpendicular lines in chapter 7.4. Okay, so here's the lesson objectives. We want to apply the conditions for the gradients of perpendicular lines to solve problems. So before I proceed on any further, okay, I probably just want to do a very simple introduction to perpendicular lines. So suppose two lines are perpendicular. So let's say we have two lines over here, and let's call this line L1 and let's call this line L2. Then simply speaking, okay, the gradient of L1, which is denoted as M1, so M1 is the gradient of L1, and I'll call M2 the gradient of L2. Okay, L1 and L2 are just the two lines you see over here. So M1 and M2 are related in this simple relationship. M1 times M2 equals to -1. Okay, let me just box this up and show you, how important this is. Okay, so just to put things in perspective, what I mentioned just now is just over here. So two lines with gradients M1 and M2 are perpendicular. This symbol over here means if and only if, okay? M1 times M2 equals to -1. Okay, so I'm just highlighting the most important thing about this chapter. So you got to know this. Okay, let's go straight to example 1a. 3 points have coordinates A, B, and C respectively. Calculate the values of t if angle ABC equals to 90 degrees. So, if ABC equals to 90 degrees, then, just to put things in perspective, I'll draw a very simple diagram. Oops, that doesn't really look like 90 degrees. Let me just redraw this a little bit. So, okay, this looks a little bit better. Okay, so this is B and this is C. So what we're saying is that angle ABC is 90 degrees. Then from this very simple sketch, we can see that obviously line AB is perpendicular. Okay, so for those of you who are not familiar, this sign means perpendicular. Okay, so line AB is perpendicular to line BC. And therefore, based on the previous statement, we can say that the gradient of AB times the gradient of BC should give me -1. Okay, this is true if and only if line AB is perpendicular to line BC. So let us proceed to work out the gradient of AB. So gradient of AB, okay, is equals to, recall your gradient formula. Your gradient formula says that it is the y coordinate of A over here minus the y coordinate of B over the x coordinate of A minus the x coordinate of B. Okay, and simplifying this, I'll have 2 over -8, which is just -1/4. Now how about the gradient of BC? So the gradient of BC is just similarly now let me use the y coordinate of C, okay, y coordinate of C minus the y coordinate of B over the x coordinate of C minus the x coordinate of B. Okay, and simplifying this, I'll just have t over -3. So what I'm going to do next is to make use of this relationship over here, where the gradient of AB times the gradient of BC gives me -1. So the gradient of AB is -1/4 times the gradient of BC, which is t over -3, should give me -1. Okay, I'll proceed on to solve this. So this gives me t over 12 equals to -1, and therefore t is just -12. And there we have it. This is the value of t. So special thing to take note for this example is the basic idea that if two lines are perpendicular, so let me just repeat this a little bit. If two lines are perpendicular, then M1 times M2 is equals to -1. Okay, let's move on to example 1b. So similarly, we have the 3 points A, B, and C, and we are asked to calculate the values of t if AC is perpendicular to BC. So let us first draw a very simple sketch. Okay, the sketch is not drawn to scale, so it doesn't have to look beautiful. So let's say we have AC, okay, perpendicular to BC. So now we have BC over here. Okay, and as you can see from this very simple sketch, line AC is perpendicular to line BC. Therefore, from this diagram over here, can you see that we have to equate the gradients of line AC and that of line BC? So, you know, to put things in perspective, let me use a different color. So what I'm saying here is that m of AC times the m, or the gradient, of BC should give me -1, okay, because these two lines are perpendicular. So let's go ahead and work out the gradient of AC. So gradient of AC using our gradient formula will just be the y coordinate of C minus the y coordinate of A over the x coordinate of C minus the x coordinate of A. Okay, and simplifying this, we will just have t minus 2 over 5. Next, let's work out the gradient of BC. Okay, and the gradient of BC is just simply the y coordinate of C minus the y coordinate of B over the x coordinate of C minus the x coordinate of B. Okay, and I'll have this. So using this relationship over here, let me just highlight this. Using this relationship over here, okay, I will equate the two gradients which I've just found. So m of AC is this, okay, and m of BC, or gradient of BC, is this, and this is equals to -1. So multiplying them together, I have t times t minus 2 over -15 equals to -1. Multiplying both sides by -15 and concurrently expanding the numerator, I'll have t squared minus 2t equals to +15. Shifting all the terms to the left of the equation and factorizing it. Okay, let me just continue over here. So factorizing this, I'll just have t minus 5 and t plus 3 equals to 0. And finally, I can get t to be either +5 or -3. Okay, and that's my final answer. Okay, so that's all for example 1b. Okay, I hope you have enjoyed this video, and we'll do more examples in the next video. So please log on to pencilcollege.com for more videos. I'll see you for now.